Okay, so I handed this sheet out to you in class today, and we did the very first step right here. So you can cross that out because that is done. Now I want to switch the order of the remaining steps. I would like to do 4 first, and then I would like to do 2 and 3 and 5. Okay, so 4 is the first one I'm going to do with you. And this is from chapter 7 and 8, okay, because some of it is ionic and some of it is covalent. And the first thing that we are going to do is draw the Lewis structure for covalent and the Lewis dot structure showing transfer for ionic, okay? So the first one that we have here is ionic, right? And so to do the Lewis dot structure showing transfer, what you're going to do is something that I did in previous notes. Mg is in family number 2. Therefore, it has 2 valence electrons. Then sulfur is in family number 6, so it has 6 valence electrons. And this magnesium electron will go here, this will go here, and then you are left with a magnesium that is 2 plus, and a sulfur that has 8 valence electrons, and it is 2 minus. That is how you do the transfer under this column for Lewis dot structure for only the ionic. Okay, so that is for ionic. Now, to do the covalent, this one here is covalent, we said in class. And we know that, of course, because this is a nonmetal and a nonmetal. Now, this is a little bit more involved, and I actually do have notes from a previous video explaining this. This is drawing Lewis dot structures. And I'm sure I'll run out of room just because of the size of, how I can write on here. So bear with me. Okay, so the first thing that you have to do is look at the elements that are present and determine how many valence electrons you have. And so I have carbon and I have hydrogen, and there is 1 carbon and 4 hydrogen, and that 1 carbon has 4 valence electrons, and those 4 hydrogens have 1 each, 4. So the total number of valence electrons is 8. Okay. Then the second thing that you need to do is look at octet electrons. Now, if you are following this, you might want to write the full word out. I'm abbreviating. Octet electrons are the electrons that we want to get. So, carbon, hydrogen, there's 1 carbon, there's 4 hydrogen. Carbon has 4 electrons, and it wants 4, so it could have octet, which is 8. So this will be 8. Then hydrogen is special. Hydrogen and helium can only have a maximum of 2. So its octet, which is not octet, will be 2. Okay, so there are 4 hydrogens, each with a desired number of 2 electrons. So that is 8. And that means that the octet electrons are 16. Okay, so after that, you are going to take the octet electrons minus the valence electrons, and that will give you the bonding electrons. And in this case, and again, I am totally running out of room, so don't, you'll be able to fit it, all of this probably right here, but I can't. So octet electrons, 16. Valence electrons, 8. 16 minus 8 is 8. That's the number of bonding electrons. Okay. And, I do number these steps often. So this is step 1. This is step 2. This is step 3. Step 4 has us taking the bonding electrons and dividing by 2. And so in this case, we've got 8 divided by 2 equals 4. And that is equal to the number of bonds in this molecule. So we have 4 bonds that we have to make. So I am going to, and I know again that you have, I'm showing this up here. Ignore this because I'm going to draw it up here. The next thing that you're going to do, and this is step 5, is you are going to draw the central atom, which is usually the first one that is listed, with the other atoms around it. And we have 4 bonds. So 1, 2, 3, 4. Each is a hydrogen. And that is 4 bonds. Now the last thing that we have to do, and this is not necessarily something that will apply to this particular molecule, and I'm just adding this step, draw structure with bonds. That's what I just did up there. Okay, then number 6. Again, I'm so sorry that this is all over the place. 6. The last thing we do is we take the valence electrons minus the bonding electrons, and that equals non-bonding electrons. Okay, and that will come into play more in other examples, but our valence electrons, 8, minus our bonding electrons, 8, is equal to 0. So there are no non-bonding electrons. If there were, what would happen is that I would have to put some electrons around the outside. But you have to remember that with hydrogen, it only wants 2 valence electrons. So each of these has 2 valence electrons, and you don't have to draw in these circles. I'm just doing that to explain. But the carbon has 2, 4, 6, 8, which is what it wanted. It wanted 8 for octet. And each hydrogen has 2, 2, 2, 2, 2. And so each of them has their octet or their ditet. I know there's another word for it, but I can't remember what it is. And that is the way that you need to check to make sure you have it set up correctly, is to verify that all of the parts of this have octet, and that is the goal. Now, keep in mind again that this line is 2 electrons. 2 electrons are shared between carbon and each hydrogen.